All right, let's get right into it. We're diving into a showdown that so many of you have been asking about. It's the battle-tested powerhouse, the RTX 3070, versus the new kid on the block, the super efficient RTX 4060. We're going to figure out which one of these is the right call for your AI setup. So you're building a new rig, or maybe you're just looking for an upgrade to get into AI. You're scrolling through options and you land on these two. One has a reputation for raw power. The other promises all this next-gen efficiency. Which one actually wins for what you want to do? Let's break it down.
First up, let's do a classic tale of the tape. We're putting these two cards head-to-head on paper, looking at the raw specs to see what they're really made of before we even plug them in.
Okay, here's the big spec sheet. I know, it's a lot of numbers. You can see some pretty big differences right off the bat. But you know what? Let's just cut through all the noise and focus on the few key specs that really truly matter for AI performance. First, we've got CUDA cores. And just looking at this, you'd think it's a total knockout. The 3070 has almost double the cores, and this is a huge but, the 4060 is running on that newer Ada Lovelace architecture. That means each one of its cores is way more efficient. So that massive gap you see, it's not nearly as wide as it looks in the real world. Now we're talking memory bandwidth. Think of this as the number of lanes on a highway for your data. And here, the difference is just stark. The RTX 3070 has this super wide 256-bit highway, letting it move a ton of data super fast. The 4060's highway is narrower. Now, it tries to compensate with a bigger L2 cache, kind of like having smarter on-ramps, but for pure data shoveling power, the 3070 is the undisputed champ. And yeah, this number right here, this is the whole story for the 3070, 448 gigabytes per second. That is its trump card. For some AI workloads, especially if you're training models or just dealing with massive data sets, that raw bandwidth can be a night and day difference. Okay, finally, let's talk tensor cores. These are the specialized little bits of hardware that make AI stuff go fast. The 3070 has 3rd-gen cores, they're great. But the 4060 has the newer 4th-gen ones. And what's really cool here is that they support new, more efficient data types like FP8. This means for modern AI models that are built to use it, the 4060 can be way, way faster. It's a generational leap. All right, enough with the spec sheets. It's time for round 2. Let's see how these cards actually handle themselves when we throw them into the real-world gauntlet of the AI apps you're actually going to use. First up, the big one, the reason a lot of you are probably watching. Stable diffusion. Generating images is super popular. It's a ton of fun. So, who's the champ here? Well, the verdict is actually kind of complicated. Right out of the box, that big bandwidth on the 3070 often gives it a little speed advantage. But if you're using optimized software, the 4060 can totally catch up. And here's the real kicker. The 4060 does all this while using almost half the power. That is a huge deal when you're letting it run for hours generating images. Okay, what about that other big AI hobby, huh? Running your own local large language models, or LLMs. Can these 8GB cards even hang? So let's have a little reality check. The single biggest problem for both of these cards is that they only have 8 gigs of VRAM. That's your ceiling. You can run smaller 7 billion parameter models, sure, but you have to really compress them down. The 3070's bandwidth might give you slightly faster answers, but again, the 4060's power efficiency is a massive win for those long chat sessions. Honestly, for serious LLM work, VRAM is king, and 8 gigs is just the entry ticket. And hey, don't just take my word for it. This quote from researcher Tim Detmers really nails it for the power users out there. If you love to get your hands dirty, write some code, and really squeeze every last drop of performance out of that VRAM, then yeah, the 3070's raw bandwidth can be a seriously powerful tool. And that brings us to round 3. We're looking past just the benchmarks and into the practical stuff that affects you every day, how much power it uses, what it costs, and which card is actually better set up for the future. Wow, I mean, this slide just says it all, doesn't it? The RTX 3070 is pulling around 220 watts. The RTX 4060 is just sipping power at 115 watts. It's not even close. We're talking nearly half the power. And this isn't just about your electricity bill. It means less heat dumped into your room, quieter fans, and you can probably get away with a smaller, cheaper power supply. It is a massive, massive win for the 4060. So when we talk about being future-proof, the 4060 just has a massive leg up. We already talked about those 4th-gen tensor cores and FP8 support, which will only get more important, but it also has DLSS 3 for gaming, and this is huge for creators, it has a modern video encoder with AV1 support. The 3070 just doesn't have that at all. So after 3 intense rounds, it is time to tally up the scores and deliver our final verdict. Which one of these GPUs should you actually buy for your AI journey? This whole thing really boils down to a choice between two different philosophies. On one hand, you have the RTX 3070, the raw bandwidth champion. It just muscles its way through tasks with pure brute force. And on the other, you have the RTX 4060, the modern efficiency king, which uses smarter, newer tech to work smarter, not harder. So here's the bottom line. Pick the RTX 3070 if and only if your main thing is a task that absolutely needs that memory bandwidth, and you can find a really good deal on a used one. For pretty much everyone else, the RTX 4060 is the smarter buy. It's modern, it runs cool, it's incredibly power efficient, and it's got features that make it a fantastic all-around card for AI, creating content, and, even gaming. Of course, if you really want to get into the weeds and see all the charts and data, you can dive deeper into our source material over at bestgpusforai.com. As always, we'll have a link for you down in the description. And that just leaves us with one last big question to think about. We spent all this time comparing two 8GB cards, but for both of them, that 8 gigs is the main thing holding them back. So it really makes you wonder, instead of choosing between these two, is the real upgrade for your AI ambitions a card that just has more memory to begin with? Something to chew on. Thanks for tuning in.